Greetings, amazing Oshkosh North students. It's your AP Stats teacher, Mr. Murphy, coming to you from room 122 at Oshkosh North. Today, we are going to be doing lesson 5.2, day 2. And let's start with trying to figure out who is this mathematician from England who lived from 1834 to 1923. And what is he known for? Here's your hint. Does that help at all? Well, it's John Venn. John Venn, and he's known for Venn diagrams. John Venn was a mathematician in England, and in 1866, he published The Logic of Chance, which was a groundbreaking book that espoused the frequency theory of probability, offering that probability should be determined by how often something is forecast to occur as opposed to educated assumptions. So that's pretty cool. It was 1866 when that happened. People would go by educated guesses, and he started coming up with the concept of maybe we should project the probability based on mathematical theories and formulas and computations. Venn then further developed mathematician George Boole's theories in 1881, were called symbolic logic, in which he highlighted what would become known as Venn diagrams. So that's part of the symbolic logic. You've got, actually with these Venn diagrams, guys, you have 4 parts. It looks like 3, but you really have 4. So you have this part inside the rectangle that's not in either circle. That counts as a part. Then you've got this part that's in this circle, but not in the other circle. Then you got this part that's in the right circle, but not in the left circle. And then you got this part that's in both circles. So there's actually 4 parts. So you heard John Venn, you're like, well, that name sounds familiar. And maybe you did hear of John Venn. But the reason it probably sounds familiar is because you've heard of John Glenn. John Glenn, the first American to orbit the Earth in 1962. Glenn circled the Earth 3 times and returned safely. As you look at this picture, you're probably going, wow, that's pretty good for a guy of his age. Well, this picture here was taken when he was 77 years old, and he went back into space for NASA again at age 77 right there. But this picture is from when he was actually going to circle the Earth 3 times. He was 40 years old. Good old John Glenn. Today for our notes, as unusual as this seems, you have to know what taco tongue is and what evil eyebrow is. So taco tongue is when you curve your tongue so it looks like a taco, like this dog. And evil eyebrow is when you have your eyebrows like this, like John Belushi's doing right there. So let's see if we can switch over to the camera at this point and go through our notes. Hey, there we go. Okay, so it says, can you taco tongue and evil eyebrow? Some people believe that the ability to taco tongue and evil eyebrow is something that you are born with. Is this true? Are the 2 abilities somehow related? So in question number 1, they want us to collect class data to fill in the following 2-way table and Venn diagram. So we're not in class, so we're going to take this data as it appears right here to be a sample of what could have happened in our class. So you got your Venn diagram over here, guys. And this is called your 2-way table because you got 2 lines across and 2 lines down. It's 2-way. You can read it 2 ways. You can read this yes for taco tongue or yes for evil eyebrow down. So 2-way table. All right, so here's our data. So how are we transferring this data over to this Venn diagram? Well, we've got for yes for evil eyebrow and yes for taco tongue, we got 15 people. So that's where you start. Start with your middle in the Venn diagram. So you start with the 15. Then you've got yes for taco tongue, but no for evil eyebrow. So that would be in the circle with taco tongue, but not in the evil eyebrow area. Furthermore, you've got 3 that were yes for evil eyebrow, but no for taco tongue. So that goes here. And then when you add these together, there's 23. There's 30 people. When you add these columns together, you got 30. There's 30 people. So that means that 30 minus 23 or 7 of them can't do either. So that's how you fill out the Venn diagram. Now let's take a look at how we can use the Venn diagram to associate probabilities. Suppose that we randomly choose a student from class. Find the probabilities of the following. Probability that you randomly selected a student that's a yes for taco tongue. Okay, there's 20 that are yes for taco tongue out of 30, so that's 20 out of 30. Yeah, you could reduce that to 2/3 or change it to 0.66 repeating or 0.67 or however you want to represent it, but let's just go with the improper fraction for today. How about the probability for no for taco tongue? No for taco tongue would be anybody that would be this here, or here would be no for taco tongue. Wait a minute. For taco tongue, for no taco tongue, that would be students that are in this part or this part. So there's 3 and 7, that's 10 out of 30. How about yes for evil eyebrow? Yes for evil eyebrow is the 15 plus the 3 or 18 out of 30. No for evil eyebrow is the 5 here and a 7 there for 12, so 12 out of 30. How about yes for taco tongue and yes for evil eyebrow? So that's the part that's in common. Yes for evil eyebrow, yes for taco tongue, that's 15, so 15 out of 30. How about yes for taco tongue and no for evil eyebrow? Yes for taco tongue, but no for evil eyebrow would be this group of 5 right here, so 5 out of 30. How about yes for evil eyebrow and no for taco tongue? That'd be this group of 3 right here. And then the last one is no for taco tongue and no for evil eyebrow. That's 7 because they couldn't do either one. How are you doing so far, kids? I hope you're doing okay. Let's talk about some mutually exclusive events. Suppose that we randomly choose a student from class. Find the following probabilities. Probability that the student is yes for evil eyebrow. Okay, evil eyebrow being a yes, there's 15 and 3 or 18. So that's 18 out of 30. Now you can also read it from the two-way table. There's 18 out of 30 there. Might be easier to actually read it from the two-way table. How about the probability of no evil eyebrow? No evil eyebrow is 12. Okay, over here it'd be the 5 plus the 7 for 12, so 12 out of 30. What's the probability that it's yes for evil eyebrow or no for evil eyebrow? Well, it's either going to be yes for evil eyebrow or no, it's going to be 30 out of 30. So 18 30ths plus 12 30ths for 30 30ths. So that gives you your formula. There it is. Probability for yes for evil eyebrow or no for evil eyebrow. So your formula is the probability of A or B is equal to the probability of A plus the probability of B. Those are for mutually exclusive events. Now, these are not mutually exclusive events, so it's going to have a different formula. And we previewed this formula in our last video. So suppose that we randomly choose a student from class. Find the following probabilities. Probability of yes to taco tongue. So yes to taco tongue was 15 and 5 or 20 30ths. And yes to evil eyebrow, that was 18 30ths. You can get that from the two-way table also. And yes to taco tongue or yes to evil eyebrow. So we would take the yes to taco tongue, which is the 20, yes to the evil eyebrow, which is the 18, add them together, but you got to subtract the ones that you double counted, which would be the 15 in the middle. That's this 15 right here. So we got to subtract the one that's in both. So we wind up with 20 30ths plus 18 30ths minus 15 30ths. So that's going to give us 23 30ths. All right, so that's it for page 1. Take a look at page 2. So we have the important ideas, the two-way table. That's an example of the two-way table. And this is an example of your Venn diagram. Notice that there's 4 places for your Venn diagram. Usually you're going to start by filling in the first spot there. then here, then there, and then lastly, whatever's left over goes here. The general addition rule for probability is the probability of A or B is the probability of A plus the probability of B minus the probability of both A and B. Okay, so if that's if they're non-mutually exclusive. If they're mutually exclusive, you can't possibly have an A and B. So you would just drop that part out of your formula and have the probability A plus probability B. If events A and B are mutually exclusive, they can't occur together. So the probability of A and B, if they're mutually exclusive, is 0. Probability of A or B is the probability of A plus the probability of B. Let's check understanding the random sample of high school students were surveyed regarding their toilet paper habits. Boy, this should be interesting. Should the toilet paper pull over the roll? Oh my heavens, we could debate this all class. Does it go over or under? Do they replace the roll when it's empty? The two-way table displays the data. Suppose we choose a member of the sample at random. Define the events. O for over and R is replace. So replaces the toilet paper when it's empty, yes or no? We come up with some interesting concepts in stats class, don't we? Prefer the toilet paper to pull over the roll, yes or no? So here's your data. Explain in plain language what probability of O complement, the C means complement, means, and find the probability. So here's a symbol. Is the probability of choosing a student who does not prefer toilet paper to pull over the roll. So the probability of O complement, O is over the roll, complement is not over the roll. Complement is the opposite. So that'd be 46 over 116, which is 0.397, make a decimal point a little bigger, there we go. So explain why the probability of O or R does not equal the probability of O plus R. And then find the probability of O or R. The events over the roll and replace when empty are not mutually exclusive. And if they're not mutually exclusive, we can't use the formula of probability of O plus probability of R. We have to also subtract the probability of both. So your probability of O or R is 70 over 116 plus 82 over 116 minus 58 over 116. Now let's explain that. 70 over 116 is the probability of O. That's right here, 70. The probability of R is 82. That's read it across. There it is, 82 out of 116. And then the probability of both is going to be 58. So we're going to subtract, and you get 98 over 116, and that, my friends, would be 0.81. Let's take a look at the Venn diagram. Make a Venn diagram to display the sample space of this chance process. You've got your over and your place, and you got your 58 that are both. So here's your 58 that are both right there. 58 that are yes for both. So that goes in the middle. You'd start with a 58. Then you'd say, okay, how many were over? It was 70. Subtract 58 from 70, you get 12. How many were replaced? Well, it was 82. So you take 82 minus 58, get 24. And then you add these together and you get, what do you get? 60, 84, 70, 94. Okay, so you got 94 people that are going to be in the circles. You've got 116 total, so you got to subtract 116 minus the 94, and you get 22. So let's take a look at that one more time. So for the Venn diagram, to display the sample space of this chance process, we've got your over, you got your place, and you got your part that's yes for both. Okay, you'd start with the middle, the 58 that are yes for both, coming from right here. Yes, 58. That's the common to both, so 58's there. Okay, then for your over, it's 70. 70 are over, so 70 minus 58 is 12. And then your replace is up here, that's 82. 82 minus 58 is 24, so you fill that in. Now you add those together and you get 94. Okay, well, we need to account for 116 people. This only accounts for 94. So take 116 minus 94 to get 22. So 22 are in neither circle. And that brings us to our last situation for our notes. Write the event does not replace the roll and prefers the toilet paper pulls over the roll in symbolic form and find the probability. So it's the probability of our complement, so not R, and O. That's going to be the 12 out of 116. So it's not in replace, but it is in the O. So all the non-replaced are over here. There's 34 that are in non-replace, but it's also in over. So you wouldn't count 22, you're just counting the 12. So it's 12 over 116, which is 0.103. That concludes our notes for today, Oshkosh North. Remember, you are the pride of Winnebago County. So stay awesome, Spartans, and we'll see you next time.